Right, good afternoon. So today let's talk about the problem every enterprise today facing. You have a mountain full of data. And we heard a lot of customers come to us is, how can we mining our data and make an AI out of it so we can better utilize it? Now today I think this session is directly addressing these problems. So here is today's agenda. First of all, let's very briefly talk about what's the Tabular predictive AI, and what's the technology, SageMaker. What's the technology behind it? What's the main features of this reference app? And by the way, it's already released on the market and a free download. What are the use cases? And we will show a live demo. So here is what the dashboard of the reference app looks like. So predictor AI. So think about you have case management, you have case records. For employee onboarding, you have onboarding processes. You have those structured data. Predictor AI is all about recognize a pattern of your historical data and to predict and forecast what's the outcome going to be when you're feeding a new set of the data. So that's what all it is. Basic information, a basic example is like the housing market, like how many bedrooms, how many square footage, what's your zip code, all those attributes all matters on when you predict what's the value on the market when you put on the market to sell the house. Now, if you put in a different attributes, the zip code, bedrooms, square foot, if you have an AI model, instantly in real time, it's going to predict, give you a number. That number we call the regression numbers, right? So for the SageMaker, right now, the reference app able to handle three kinds of scenarios. First is a binary value, which just as I said, is a predict of the value like an integer or decimal. For this example, will be the house market value. The second one will be the yes or no binary prediction. Like say, is that for example, will be a fraud detection model. Is this a fraud or not? Yes or no. The last one will be multi-category classification, such as if you want to use an AI model to predict, I bring my vehicle to the shop, what recommend for the next service you're going to recommend? Could it be a oil change? Could it be a change my brake pad? Could it be change my wiper? Could be multiple possibilities. So that will be a multiple category regression. So those three types, the SageMaker able to handle. So let's talk about what's the technology behind it. So in order for SageMaker to be the technology, the main one here is in the middle called the SageMaker pipeline. SageMaker pipeline is do the heavy lifting of you enable us as a developer to create, training, tuning, deploy the model, the machine learning model in streamlined process. So that's the SageMaker, the pipeline does automatically, right? I just want to highlight when we say the training, what happened under the hood by SageMaker pipeline is it's automatically run dozens of experimentations under the hood without we notice. And it will automatically recognize what the pattern is. It's a binary, it's a regression, or it's a multi-category classification. It's utilize the best algorithm for that category, run dozens of experimentations, and find the best outcome automatically for us. So we don't need to using a data scientist PhD to do the hyperparameter tuning to find out which the best algorithm for us to use. The pipeline automatically does that for us. So in order for AWS to share that technology with us, they have to outsourcing that, open source the product. So they put the project on the GitHub, and then Appian forks that as a branch and hosted in Appian GitHub. And what we did, or I did, is create a bunch of the Lambda functions to enable the integration from Appian applications with SageMaker. Right? So the SageMaker provided a pipeline, and the integration allow us to integrate with the endpoints, integrate with the models. So not only you can deploy the endpoint, also you do some administrative tasks, such as I don't like the model, I want to delete it. I don't like the endpoint, I want to delete it. So those the house cleaning, that's what the reference app added value to you. And don't worry about the link. The link is also included in the slide, added the last slides as the additional source. So if you want to reading through the technology behind it, and also including the deployment steps, we make it so easy because first time you only need to deploy the pipeline using run the CloudFormation script. Once it's there, the rest is easy. The rest is all just a single uploading your CSV file. That's it. So the key value proposition of the reference app, as I said, is it do the heavy lifting to allow the user to simplify the complicated world of machine learning by streamlining the model create, training, tuning, and deployment in one single reference app. It's all started with a business user without any extensive data science background. You can do it. All you need is a data set in a CSV file. And I will talk about it when we show the video snip of what's the Excel, the CSV file looks like, right? So first, you have to make sure you have a header row, because the model need to know what's the column is about. Second one, you need to rename one of the column you want the model to do prediction on, just rename called target. So every time that our pipeline finds the target, it knows this column I want to do prediction on. So that's it. That's all the two requirements for your CSV data file. Another one I want to highlight is this model. I bundled 6 ready-to-use use cases across 6 different industries, such as financial sectors for banking, for detect if a loan going to default or not, for marketing, for customer chain, for healthcare pharmaceutical to predict if the patient is likelihood to get a diabetes patient or not. For service industry, the vehicle recommend what's the next service going to perform. And for supply chain, to predict what's the likelihood of what type of the breakdown type going to be. So, and the last one, the insurance, to predict what's the medical expense for a given customer or consumers. So insurance underwriter can use that information to decide what's the premium they're going to charge you based on your medical expense forecast. So let's look at some common industry use cases. So for banking, KYC, know your customers. The anomaly detection, customer risk score, it's a very common one, using a prediction score. The insurance, recommend which insurer should use. And interesting, this one is look at how long it might take. So it matters. Probably you're going to pick the one that give you the shortest time to do the insurance underwriting. And the case management, case loading, risk scoring, we hear that a lot from our customers. How can we do the case loading based on using AI model to predict rather than we have a human to decide? So here is the dashboard snapshot for those 6 use cases included in the reference app. So let's do a demo. Before we jump to the live demo, first I want to show the 2-minute video snippet of starting from the beginning. You have a data set, upload it to all the way down, you have the model deployed and give you the REST endpoint. That's all you need. You have the REST endpoint, you plug in the designer with the integration object, you're done. So here we go. So that's the interface. First, you have an S3 bucket, you give it a name, you drag and drop your CSV file, and you acknowledge first thing, the two requirements. Your CSV have to have a header. Second requirements, make sure you have a target name for the predict column. And a pipeline, each department could have a separate pipelines. So that's when you first time you deploy the pipeline, you get a name. And of course, you name it, what's the model name you're going to give. So that's it. And then next one, you just wait. Usually take 45 to 80 minutes, depends on how big, how complicated your CSV data set is. When it's ready, you refresh your screen, you will see the model change from executing to succeed. At that time, you know your model is ready. Now, next steps is to deploy the model. It's streamlined process, wizard-driven, like a TurboTax. So you have a choice of what kind of instance you're going to choose to host the model. Out of box, we provide 3 types of the instance type. The more powerful, the fast for inference. This one will pretty quick, less than 5 minutes to deploy the model. When they come back, it will tell you now your endpoint is in service. You refresh your screen. Your endpoint is deployed. It's ready to be to do the business, to do inference. And here you can tell, if I stop here, so that's all you need. Here's the endpoint URL. That's the REST endpoint. You can just copy paste and go back to your integration object and hook up. So you can make an HTTP integration. And then once you have the integration built out, you can use that in your SAIL language, anywhere you feel fit. Right? Now let me switch gear to the live demo, how we use it, right? So let's first say, go to financial services. Okay, so suppose this a customer walking to my bank, the branch, on the spot want to apply for a new loan. And we collect all data, what the loan amount, what's the purpose, how many inquiries this consumer has been about this loan for the last 6 months. So all those information. Now for I provide a markup data set. It's automatically fill those data for me with a single click of the button. That's a real-time AI power right there. So this one tell me, it gives you 2 results. First, it gives me that it's a fully paid, which means not going to be default. And the second one, it tells me confidence level is 71%. Now it's up to each of the organization to decide. 71% is it good enough or not? For some kind of enterprise, that's pretty good. For some, now I'm not going to accept it unless it's 85 or 90%, right? So you have to fine-tuning it, make sure it's to the level you feel comfortable with. Now the business value is the prediction AI is all the purpose is to aid the business users with a decision, to help them to make intelligent decisions on the spot. So how does so? So for this example, I know it's not going to be default. Then on the right, I want to automatically recommend products on the spot, sell to the customer. Let's change gear to say I change a different set of data. Now let's do the prediction again. Now it tells me for a different customer, it's going to be default, 65% confident. In that way, why bother to recommend a product to sell? If I know this customer more likely going to default. So this is show you the value to using a real-time prediction AI to help your business users to make intelligent decisions in their daily life. So that's just one example. Let's pick another one. Let's say insurance. So this insurance, if for insurance I want to charge a premium, I want to pricing my premium. First, I need to know what's the medical expense forecast for this particular applicant. So for a high medical expense applicant, the medical expense prediction probably is $11,000. What about for a smoker? That will be $15,000. So that's a significant jump. So with that, I probably we're going to charge significantly high for the medical expense for the premium, right? So last one, let's see for multi-category classification for predictor, recommend the vehicle maintenance service to perform for this particular vehicle. Let's say this one, it gives you multiple recommendations, and you pick the highest one, which is the oil change. 89% is recommended based on that vehicle mileage, when the last time performed, oil change, so and so, right? So there's a multiple category of the classification. Something else is provided in the 6 use cases. Each one comes with a data set. Will tell you where's the original CSV data set pulled from. So if you want to know more, you can read more to find out. The model report will be the matrix to measure the performance, how good is this model. So for this one, precision level, not that much high, but the accuracy is almost 70%. Right? And then you can go to the AWS SageMaker, the blog post or documentation to reading through what's the F1, F2 value is. I just want to point out for different organizations, they choose different model metrics. For example, for medical industries, the negative is way more important than positive, because negative, if you failed, that bring critical consequences. So they choose certain matrix. It's different, depends on the industry you're using. Here is the confusion matrix. And the last one is the feature report. Feature report is about tell you the nature of your CSV data. Basically tell you about your data set, which attributes carry more weight when do the prediction. So very useful. So this is the 6 use cases from 6 different industries. Okay, one now. So this reference is enabler and accelerator for you to turn your enterprise extensive raw data into actionable insight and prediction. If you ask me, is that good for production use? My answer is probably not. So what's useful? Useful for you to turn your ideas. I have this data set. I just do not know, can I turn this data into an AI model or not? Use this tool, fit your purpose very well. It's very quickly to tell you, even it's not that accurate, but to tell you very, very quickly. Your data set, yes, at least point to the right direction. That's the direction is right. You probably can start working on that one. Or you can fail, but fail very, very quickly, tell you, no, that data is bad. Don't bother because you waste your time. Garbage data doesn't, the model tell you that doesn't make any sense for any prediction because all the value is so low. So that's the tool is an enabler and accelerate to streamline your journey from data to decisions.